Okay, so I put number 4 up there first, just because, I mean, like on number 1, I'm just gonna tell you, type that in your calculator, you know, so. Christian, what are you looking confused about? Alright, so it gave you 3 points on that graph on number 4, and I just chose the smallest 2, so that's what I put up there. If you used that other one, you're not wrong. What does that look like? It would be on 5/16 maybe? But one of the things, that 2, I had originally counted wrong. You had to look at that graph and figure out what they were counting by.
Yeah.
And so that would
That's
make
why.
a mistake, yeah. So be careful and look and figure out what they're counting by. So we're gonna plug those in to our y equals AB to the x, both of them. So I would say 2 equals AB to the second, and 8 equals AB to the fourth. And then when I did it, I solved the first one for A, so I divided by B squared. So let me get some room to work here. A is equal to 2 divided by B squared. So then you take that and you substitute it in, remember in this? 8 equals 2 divided by B squared times B to the fourth. Then you reduce your b's, so what's b to the fourth over b squared reduced to?
B squared.
So you got 8 equals 2b squared. Then you divide by 2, so you get 4 equals b squared, and then you undo the squared, so you square root, and you got your b is 2. Now, that's as far as I went when I was working it, because I looked at the choices. A's got a b of 2. B's got the 2 in the wrong spot, so it can't be it. C doesn't have it right, and D does, so it had to be A, right, based on the choices. If there was a couple of them, you would just plug that in here, plug it in, 2 squared is 4, 2 divided by 4 is a half. And that's what they did on the choices, they tried to flip those halves and 2s to try to trick you. So just make sure you know which one's your A and which one's your B, okay? Alright, so I'm gonna flip back to the front and we'll see how you did on the first 3. Let me erase that so I can use that bell on the bell ringer again. Alright, on number 1, you just type that graph into your calculator. What did you get?
D.
It was D as in dynamite. Ready to get D for number 1? Okay, same thing on number 2. Just type it in your calculator. What'd you get on it?
A.
8. Very good. Alright, number 3. I'm just curious. I'm gonna do it with you, but I'm curious on what y'all put on 3. Tell me what you put. Got a C?
C.
C?
I think so. Yeah.
C's not right.
Okay.
So we were 0 for 3. So the deal on this one, and we wrote this down.
Or was it D? Did I look at it?
No, it's not D. We wrote this down,
Those were my twins.
just maybe one time. I don't know why I put A. Let me erase that and write Y. When it was a growth, you were always 1 plus. If it was a decay, you were always 1 minus. So on this one, it says the population of quail is increasing, so it's a growth. So they started with 895 quail, and then they increase, so 1 plus 0.07. And so that would make 1.07, which would be A. So don't forget that 1 plus when you're doing that growth. So we just did number 4, so now number 5, you're gonna know better because of what we just looked at there. It says find the percent increase. You get a new piece of paper, find the percent increase or decrease from that model. 0.35 times 2.3 to the x. Okay, so it's bigger than 1, so it had to be an increase, right? So 1 plus what would get you that 2.3 in there?
1.3.
1.3. So now make 1.3 a percentage. Right? So that would be B, as in Boomland.
And I got it.
Good job. Alright, number 6, it tells you to use the graph of y equal e to the x, but you don't have to do that. Your E button, remember, is second L in, so hit second L in and then put your 1.7 up there. What'd you get on number 6?
And
A. Very good on that. Alright, number 7 could have tricked you. I underlined the word continuously, so I knew which formula I was using. There's your continuous formula. But what they did to you on this one is they gave you different information. So it said how much money invested at 5%, so your rate would be 0.05. Compounding continuously for 3 years, so your T is gonna be 3. And then the trick here says will yield $820. So if it's gonna yield $820, does that mean $820 is what we put in, or does that mean that's how much we ended up with?
How much we end up?
Yep, so that means our A is $820. So we're solving this one a little bit different than the ones we have in the past. So we would say $820 equals, we don't know, times the number E to the 0.05 times 3 power. Okay, so then what you're gonna do is you're gonna put this in your calculator, E to the 0.05 times 3 power. That's gonna be being multiplied by P, so you gotta undo that and divide by it. So 820 divided by whatever this is. Okay? I got like about 1.16, just so you get a ballpark of what's happening.
Okay, so you said once we get that, we divide 820 by number, and that's what our cost would be?
What'd you get?
I think I put it in, was it D?
Yeah.
So I was right. I did put it in there.
Just seems like a weird amount to take to the bank, you know, like who's got, maybe they had it on a check or something, get 78 cents out of your pocket or whatever. That'd be Christian.
yeah.
Alright, so number 8, you can plug that into the graph on your calculator, and those graph ones are quick and easy, cause you look at your calculator, you look at the pictures. So what'd you get on that one?
C.
C is correct. Alright, number 9, 9 and 10, we're expanding. So means we're gonna be using our properties. So we got log base 3 of 11p cubed. So 11p means 11 times p, so we got product. Cubed is a power, so we got power. So we got both of those happening. So I'm gonna write log base 3 of 11. Product property is friends with addition. Okay, now I gotta bring that power down, so that'll be log base 3 of 11 plus 3 log base 3 of p. Is that right? C?
I got C.
Alright, number 10 was a tricky one. Where in all those choices that have 1/2 did they get a 1/2 from?
Is 57 over 74 reduced to 1? Well, no, then.
No.
It is not C.
That's a darn.
Think about, if I wanted to rewrite the square root of 57 over 74 using power over root. What's the square root the same as? Power over root. No. What's the power of 57 over 74?
1.
1, and what's the root? Right, it's a square root, it's a 2. So wouldn't that be the same thing? Yep. So now I've got quotient property and I've got power property. So this whole thing was underneath the square root. So that means this whole thing gets that power. So I need to make sure I know that it goes to both the numerator and the denominator. So I'm going to have log base b of 57 to the 1/2. Quotient's friends with subtraction minus log base b of 74 to the 1/2. And now we're going to do our power property. Bring those down front. Half log base b of 57. And I couldn't tell if that was a b or an h on that test, so if you put an h, that's okay. Minus a half of log base b of 74. Which was B, as in Boomland. That one I thought was one of the trickier ones for you. Alright, number 11, we get to solve. I like solving. So we got 15 to the 2x is equal to 36. So what would we try to do here to start solving that?
Put it in the log.
Very good, so we would write log base 15 of 36 is equal to 2x. Then we hit math and go to log base on our calculator. I think I got approximately about 1.32 when I did that. So my last step now, sometimes we're done there, but this says equals 2x. So we need to divide by 2. Did you get A? Good job. Good job. Last page, but it's got the most problems on it, doesn't it? Number 12, 125 to the 9x minus 2 is equal to 150. Okay, started the same way as we did the last one, looks like the same kind of problem, right? So log base 125 of 150 is equal to 9x minus 2. So log base 125 of 150 on your calculator, close to 1.04 maybe. Now we just got a two-step equation to solve. Add 2, and then divide by 9. C, is that right? 0.3375? Now, they're tenths, hundredths, thousandths, 10 thousandths. They're rounding all this stuff to 10 thousandths, which is good. I mean, the more digits you give, the more accurate your answer is if you're concerned about that. So what the best thing to do is when you get this in your calculator, leave that in there and use all the digits so that when you get here, you're closer. You know, like I chopped it off at hundreds, so that's not near as accurate as what they're doing. Does that make sense? Alright, so on 13, still solving, just solve several in a row here. We got log of 4x plus 10 is equal to 3. Okay, so we've changed forms now. This one's got a log in it, so it's in log form, so we would rewrite it into exponential form or bin form. But there's no base, so what's our base?
10.
So I got 10 to the third equals 4x plus 10. Okay. So 10 to the third, is that 1,000?
Mhm.
Zeros mess with my mind. Okay, so your two-step equation, subtract your 10, divide by 4, what'd you end up getting?
$247.5.
Number 13, 247.5. Okay, but what do we do when we see that's not a choice? No, there's no rounding up.
Oh, the fraction.
Yep, check those, see if you can put it in a fraction. I believe B is the equivalent
Mhm.
fraction.
Yeah, I would think 7 over 4 goes to 240.
And that one's negative also.
Yeah.
Alright. 13 and 14 we solved, but we have to know our properties to solve these. So 14, right, 14, yeah. We got 3 log 2x equals 4. So we got this 3 out here that's, we gotta deal with. Now, a lot of people will make a pretty common mistake. They'll say, well, that 3's being multiplied, so I'm just gonna divide. Logarithms are kind of special. They got different rules than normal equations. What has to happen here is you have to recognize that's the power property, and you have to do that. So we're gonna have log of 2x cubed is equal to 4. Now, when you cube that 2x, you have to cube the 2 and the x. So I'm gonna go ahead and write log of 8, 2 cubed, x cubed equals 4. Okay, so now we've got our log form simplified, so we need to rewrite it in exponential form. So again, we have an understood base of 10. So 10 to the 4th equals 8x cubed. Okay, so 10 to the 4th, I guess that'd be 10,000.
Mhm.
Equals 8x cubed, so then divide it by 8. What's 10,000 divided by 8?
1250.
And then we need to undo the cube by cube rooting. So in case you forgot cube root on your calculator, it's math 4. Uh, 10.7722. Cube. Did you get that right on your own?
Yeah.
Good.
Plugged it in.
Yeah, and I've told y'all, you can always, if you've got time, and that one was easy because it was A, it was the first one, so you can always plug the choices in and work backwards.
It never fails if I plug stuff in. I'll start at A and it'll always be D, but if I start at D,
It'll
it'll
be
be A.
Alright, so 15, gotta use property again, log of 3x plus log of 9 equals 0. Because we got 2 logs there, we need to condense that to 1 log, so addition is friends with product properties, so we're gonna multiply on those. So log of 27x is equal to 0. So our base is an understood 10 again. So this is weird, 10 to the 0 equals 27x. What's anything to the 0? 1, so 1 equals 27x. So divide by 27. Is it B?
Yes.
0.04? Boomland.
I think I've been there before.
To Boomland? In Indiana?
Yeah.
That's crazy. I've up in there too.
A little bit to the other side of the United States.
Farthest I've been in the United States is Florida, unless you count flying to Atlanta and then Africa.
Well, that's pretty fun.
Yep.
Where'd you go in Africa?
We landed in South Africa and then drove all the way up to Namibia
Ooh,
and stayed for almost a month.
yeah.
It was
I went to Angola, Africa for a couple weeks.
We planted a banana tree while we were there,
Well, that's pretty neat.
and
Go to the-
well, I think it's actually producing bananas now,
Cool.
which is cool. And they've also got a lemon tree out there next to where we planted it. So it's a dangerous lemon tree though. And thorns on it that long.
Really? I didn't know lemon trees had cool. Guess I never seen one.
Crazy.
Okay, so 16 and 17 we're condensing. So we gotta take these two logs and condense them to one. Remember I told you Friday, Thursday, one day last week, ln is natural log. And so I'm gonna make us a little note over here, and I just told you this, you might not have written it down. ln natural log is the same as log base e. Okay, so that's gonna come into play on these problems here. Alright, so first thing we need to notice is that we got power property and we've got product property. So I'm gonna bring that power to cube that, and I'm gonna bring that power to cube that. So I'm gonna have the natural log 3 cubed, 27, right? Times c cubed, right? Okay, so far. Now we, no, we don't have to use, I thought we were gonna have to use this stuff I wrote for you over here, but we don't, it stopped there. So that's your answer on that one, D. Alright, so the next one, we got 3 natural log of A minus a half, and we remember what that means. Natural log of B plus natural log of C squared. Alright, so this 3 is gonna go to the A, minus this quotient, so I'm gonna divide by all of this, but I also have to put that with all that, that with all that, that's good terms, isn't it? So we got the natural log of A cubed divided by, I don't have to write natural log again, remember I'm trying to condense it down, that's the point. So B to the 1/2 power. And when I do the 1/2 power here to the C, what 1/2 times 2, what happens to that?
It becomes 1.
Right, so I just got a C. Okay, so I wanted to be done there, but there wasn't a choice that said that. But we got reminded on an earlier problem that this 1/2 power down here is the same as a square root, isn't it? So a natural log of A cubed divided by, I just put the C first so that I didn't get confused if it was underneath my radical. So that looks like D is a 909. I thought that one might have been a little tricky, just remembering that 1/2 stuff. Alright, 18's a fun one, lawnmower talk. I always like to talk about lawnmowers. Says the sales of lawnmowers T years after a particular model is introduced is given by this function. Y equals 5,500 times the natural log of 9t plus 4. Where y is the number of mowers sold, how many mowers will be sold 2 years after the model is introduced? So 2 years, I'll put a T, 2 in for T. So that's 9 times 2 is 18, so I got y equals 55 times the or 5,500, dumb butt, don't lose those zeros, that's important lawnmower stuff. 5,500 times the natural log of 22. And now that's just a calculator problem for you. Remember, natural log is on the far left over there by the neighborhood of the 4, I can't remember exactly. So just be careful and type all that in and see how many lawnmowers we sold. How many?
Huh?
Oh, you didn't get it yet?
17,000.7.
17. Okay, so you can't sell a part of a lawnmower, so 17,000 lawnmowers.
I didn't think that was the right answer, it was so big. Math would do that to you.
Okay, 19 and 20 we're both solving, and these are the two I was thinking about where we needed to know our log base E stuff. I knew it was on here somewhere, I forgot where. Alright, so solve natural log of x minus natural log of 6 is equal to 0. So we got two logs there and a subtraction sign, so we're gonna use the quotient property to rewrite that. So it's gonna be natural log of x divided by 6 is equal to 0. Okay, so that is in log form, even though it's a natural log. So we need to rewrite it into exponential form. But to rewrite it into exponential form, we gotta substitute that log base e. So this is gonna be log base e of x divided by 6 is equal to 0. So now we got a base of e, an exponent of 0 is equal to x divided by 6. Looks horrible, but it's really not, because anything to the 0, even e, is 1. My variable's being divided by 6, so I'll do that and multiply by 6. 1 times 6 is 6, which was A. Alrighty, last one. E to the x is equal to 3/4. So again, remember, natural log is the same as log base e, because we're in exponential form. So to solve this, we gotta rewrite it into log form. So, I've got log base e greetings. He is virtual. Yeah. Alright, bye. Send Zach right to the office. So log base e of 3/4 is equal to x. Okay, so you could type in log base and go fill in an e and a 3/4 and do that. It was easier for me to, less keystrokes for me to screw up, remembering that log base e is the same as ln. So that's the way I typed it in. So ln of 3/4, and I got negative 0.288. So make sure that's what you get. Get it there, T. Alright. Feel alright? Feel make an A?
Something like that.
Hopefully.
Good. Alright, well, we're planning on doing it on Thursday. I know it's a craziness, but